Okay, so here we go. Our next lesson is going to be area of a circle. And we've talked a lot about area the last few lessons. This one is obviously looks a little bit different. We've done area of a rectangle was our first one. We did area of a triangle was our second one. And as we know, triangles were based off the formula for area of a rectangle. And then we did area of a trapezoid, and we discovered that, the next one we did was area of a parallelogram, and we discovered that it also was off of based off of a rectangle. And then we did a trapezoid, which we found out was also off of the area of a rectangle. And then we come to circle. And so as we look at this, we're probably going, okay, well, that's cute that all the other ones were based off area of a rectangle, but there's obviously no way that a circle could be based off area of a rectangle. And so just for kicks, what I'm going to do is I'm going to go ahead and write the formula over here for area of a rectangle, and that's A equals base times height. And the reason that I write over there off to the side is because we need to have a base and a height in order to use that formula. If I don't have a base and a height, then there's no way that I can find the area of that shape. So it makes sense that the circle, because I don't have a base and a height, because there are no right angles in the circle, it makes sense that formula wouldn't work for area of a circle. Okay, so here's what I'm going to do though. Instead of using that formula, I'm going to go ahead and manipulate this a little bit like we've manipulated the other one, just so that we can see it a little bit easier and how we might do it. So what I'm going to do first, and if you actually have time and you want to do this, you can actually follow along with the video and actually cut this out. So when I say cut, you actually could be cutting out a circle and cutting out the different lines. So the first thing you would start with was you'd start with a circle. And then what I want you to do is to cut the circle into two circles, or into two semicircles, excuse me, or cut it into half, basically is what you're doing. So you're going to end up with two different halves. We're going to call this one the blue half, and it's the top like that. And then we'll talk about the bottom being the red half, and it's down there like that. So we have two different halves of the circle. So I'm just going to separate this out so that I can see my blue half goes like this. Okay, that's pretty terrible. I'm going to try that again. My blue half goes like that. That's a little bit better. And then my red half goes like this. So now I've just taken those two halves, those two semicircles, and I've just separated them out. Again, my picture's not great. Don't look at the size of it. Okay, then what I want you to do is, if you're cutting this out along with me, from right in the middle of your blue line, I'd like for you to cut from the middle towards the outer edge, but notice, don't cut all the way through. So I don't want you to cut all the way past the edge to make these into little triangle looking things. They should be one piece still. So you're cutting from the center to the outer edge, but don't cut all the way through the paper. And again, do the same thing down here on the red, going directly from the middle. You cut outward, but you don't cut all the way through the paper, meaning don't do that. Don't go through the paper. So you're going to cut as close as you can, but not go through it. And again, it doesn't really matter how thick you make those. The more slices you can make, the better, but it's not that big a deal. Okay, so then what I want you to do is to take your blue one, or in my case it's blue, I don't know what color yours is, and to kind of pull it apart so that it looks like there's teeth, like this. And then, it depends on how many of those you did. And then this part right here, whoops, let me get a little thicker line there. I'm going to change this outer edge here. Okay, that's this part here, just so we're kind of clear what we're talking about. Okay, that is right there, and it would be a little bit humpbacked like that. So I tried to make some little humps in there. It's not going to be perfectly straight across, but it's going to be pretty close. And then do the same thing with the red, except of course it will be facing the opposite direction. Whoops, I don't want to use that thick line, I want to use a thinner one. So it would look like this. Something like that anyway. And then again, I'll use a little bit different color for this one. Let's use maybe that pinkish thing. So then that is going to be this pink. Oops, let me get thicker. This pink right here is the same as this pink right here. Okay, so that's that part. And again, it would go like this. And again, there'd be little humps there. It's not perfectly straight, flat across. So then what you do is you're going to push those two together. So you're going to slide this one that way, and you're going to slide that one that way. So if the teeth slide into one another. And what you'll end up with is the blue one will look like this. And it'll have the little green going around the back side like that. And then the red would fit right inside of there. And it's going to have that pink color going like this. And again, the little humps. And what you notice is if you cut these pieces thinner and thinner and thinner, then they actually would create a rectangle, with this basically being straight, this being straight across, that being straight down, and that being straight across. So the thinner you cut those slices, the more up and down you can get, and theoretically we could get it so that this basically would be going straight up and down, which would then create a right angle or a rectangle. So if I can manipulate this shape into this shape right here, then that means I can use this formula to find my area. The question is, how does this relate to this? Well, earlier in the week we learned how to find the circumference of a circle. And if you remember what the circumference of a circle was, the circumference was the measurement all the way around the outside. So the formula for circumference of a circle, if we remember, was C equals pi d. And I told you that's my preferred one formula for finding the circumference is C equals pi d. But we also learned there was a second one that I don't like as much because students get it confused with the area formula, and that is C equals 2 pi r. Now, even though I don't like this formula for my students to use, this formula is useful for us to find the formula for this area for this shape. So I'm actually going to use 2 pi r for the proof of what the formula is. So if we look at this part right here is green, and this part is green right here. And this part right here is this part right here. So if I kept cutting it thinner and thinner and thinner, this green line would lose those little humps and it would eventually become straight. So this line right here actually is my green right here. So this green right here is the same as this green right here. And this green right here is half of my circumference. So for the base, the base of this rectangle, the B is equal to the circumference, which is 2 pi r, but I only want to have half of the circumference, not the whole circumference. So I only want half of the circumference. So it'd be 2 pi r divided by 2. And so what we notice is these right here is the 2's are going to simplify out and make a giant 1, which means the base of this rectangle is equal to pi r, or half of the circumference. Okay, and that makes sense. If the circumference here is pi d and the radius is half the diameter, then that means half the circumference would be just pi r. So that makes sense that this is going to be equal to pi r. Okay, so that's great. That gives me the base here. But how do I find this height? Well, if we think about what we did, we came back over here and we went from the middle of the circle out to the edge as close as we possibly could. So what do we call it when we draw a line from the middle of a circle out to the edge? Well, if we got closer and closer and closer to that edge, then we could say that going from the middle to the outer edge, that's a radius. So that means from here to here is a radius. From here to here is a radius. So that means that here is my middle of my circle and cutting out to my outer edge. Middle of my circle cutting out to my outer edge. Middle of this part of the circle cutting to the outer edge, which means middle of this circle cutting to the outer edge. And if these slide into each other, then that means that this distance from here to here is going to be the same as the distance from here to here, or from here to here, which then of course is a radius. So if I have my formula, which is area, whoops, I don't want to have that thick one. Area equals base times height. And if I'm saying that my base is pi r and my height is r, then my formula, my area formula, is going to be area equals pi r squared. And that, of course, is the formula for area of a circle. So strangely enough, even a circle is based off of the formula for a rectangle, which is area equals base times height. We can manipulate this shape into this shape, and then by understanding what the different parts of the shape are, that this part here is this part here, we can then plug it in and find the area equals base times height. All area is based off of the equation area equals base times height. Okay, now let's take a look at a couple of practice problems. So here we go. Here we have a circle, and the area of this circle is what we need to calculate. And so what we're going to start with is what we always do, and that is the formula for the shape, which is area equals, which we just learned is pi r squared. And so what I need for this is I need to understand what the radius of my shape is. And if we look at it, what it gave me was a diameter. The diameter goes all the way across. So that means the radius is only going to be half of it. And so if they gave me the diameter of 14, so if d equals 14, then r must equal 7. And so then I go area equals pi times 7 squared, which is area equals pi times, and 7 squared is 49. And as I mentioned to you earlier this week, that we're just going to use, I know it's really 3.14 blah blah blah, but instead of using even 3.14, we're just going to use 3. So 3 times 49 is 147, but I did something wrong, and what I did wrong is I don't want to say equal to, I want to say area is about equal to 147 units squared. Okay, so that's what we're going to use, is we just change the pi into a 3, and it's about 147. We should know it's more than that, but I'm not going to stress too much about it. If you really want to find out what it is, grab a calculator. Okay, let's take a look at one more example here. So on this one, it's a little bit easier because they gave me the radius, so I don't have to do any extra calculation to get that. I'm going to go straight to my formula, which is area equals pi r squared. And so for this one, I'm going to say pi, that stays the same, and my r is 8, and my square. What I'd like to point out here is you notice through the notes, every single time I've replaced a letter with a number, I always use parentheses. That's an excellent math habit that we should all have and instill inside of our students as well. And then excellent math habits would also be understanding and knowing why the 2, the square, is outside the parenthesis. And the reason the 2 is outside the parenthesis is because all I'm replacing is r. What r is equal to is 8. That square is coming from the original equation, so it should not be inside the parentheses. Technically, it's incorrect if you had the square inside the parenthesis. Okay, so then my next step is going to be pi times 64. So that's 8 squared is 64. And then my last step is the area is equal to or about equal to, and then 3 times 64, if we can't multiply that in our head, that's certainly okay, but I believe it's 192. You may want to check my math on that, but I believe it's 192 units squared. Okay, so that is our area of a circle, and one of the main, it's pretty easy to manipulate it once you learn and memorize this formula right here. It's not too bad. One of the main things I want us to be able to do is I want us to be able to prove why that formula works. So be able to show me by cutting up and using pictures how this formula right here is based on the area of a rectangle. So that's the major thing from these notes. And then of course the manipulation of it is required. Okay, that's it for these notes. Make sure you add anything you need to, and have a great weekend.